Okay, grade 8, this is a four-fer in review for your Chapter 9 test on linear relations. These 4 questions are basically all of the different types of questions you should be able to answer for your test. If you're given one thing, like you're given a graph, you should be able to give me an equation and a table of values. If you're given a table of values, you should be able to give me an equation and a graph, and so on and so forth. So there's 4 questions. The first question is I give you a graph, and the points on the graph appear to be linear because they appear to make a line. The data is not given, so you don't know what the x represents and you don't know what the y represents. So there are no special values. It's just simply the x-axis and your y-axis. So the first thing I'm going to do is I'm going to define the 4 points that I know, or the 5 points I know. So the first one, since this is your x-axis and this is your y-axis, the first point is this one right here. And on your x-axis it is 4, and on your y-axis it is 1. So the first point is called a 4, 1. Okay? Your second point right here would be an 8 on the x-axis and a 2 on the y. Your third point would be a 12 and a 3, and the fourth point would be a 16 and a 4, and I suppose since there is a fifth point, it is 20 on the x-axis and 5 on the y. Okay? So the first thing you need to be able to do is graph, or is to plot those points on a table of values. The second thing you need to be able to do is take this table of values and determine the equation that represents the relationship between x and y. So before you search for that relationship, you should always write this part down here, leaving space for your coefficient if there is one, and leaving space for a constant if there is one. And then we're going to procedurally look for what are those points. Now the first one is to find your coefficient of your equation, which is your multiplier for x. You will take the difference in y, which in this case is 1 each time. So the difference in y divided by the difference in x. In this case, it's going up by 4. So that means your coefficient here is a quarter. Or another way to put that is in decimal form, a quarter. Or another way to do that is to simply say a quarter. All 3 of these are correct. Now because this is probably the easiest way, because we did say division, this is probably the easiest way to put your coefficient, a quarter of x. So 0.25x. Okay? I prefer this way because in algebra, we tend to use, instead of saying a quarter of x, we usually use this way to say a quarter of x. But both are representing a fractional part of x. And we can remember when we did our algebra tiles, if this is x, this would represent both a quarter of x and a quarter of x. Okay. So once you figured out your coefficient, then the next part you have to do is figure out if there is a constant. And the way we do that is we take any of the ordered pairs. I'm going to always take the first one, and I take my equation and I substitute the x value in the equation, and I substitute the y value in the equation. I then see, so 0.5 or a quarter times 4 would be 1. And then I see if both sides are equal. If they are equal, that means we do not require a constant. In this particular equation, they are equal, which means you don't need a constant, which simply means your equation is 0.25x will equal y, or, so that means 0.25x equals y, or better yet, a quarter of x equals y. And we can see that with any ordered pair we substitute in there. If we did x is 16, so we go a quarter of 16 is 4, so that works. So for every ordered pair on this line, the equation is a quarter of x will always equal y. And that's your answer. In the second question, I think, in the second question we have an equation only. And you're asked to fill in a table of values, which I already started doing. And graph them. So the first thing I'm going to do is I'm going to take my, actually I'm going to erase this because I want to do it again. So this is what you're given. And when you're given an equation, the first thing you should do is write down x and y and define any points for x you want. In this case, I'm going to do 0, 1, 2, and 3. Okay? And when x is 0, and when x is 1, and when x is 2, and when x is 3, the value of y is going to change each time. So if I take my equation, I'm just going to triple it right here. I'm going to go infinite cloner. I'm going to go double it. And then I'm going to triple it. So when I take this equation and I substitute a value of x, so in this one I'm going to substitute the value 0 for x. In the next one I'm going to substitute the value 1 for x. And in the third one I'm going to substitute the value 2 for x. And in all three of those, when I simplify this side, the corresponding value of y is going to be different. So when I simplify the first one, I get negative 2 plus 2, or plus 0, excuse me. I got to follow order of operations. And negative 2 plus 0 is negative 2. So when I simplify that left-hand side with x being 0, I get negative 2 as a simplification, and therefore negative 2 equals y. So I can plug that value into my table of values. When x equals 1 over here, I can simplify it. Negative 2 plus 2 is 0, and therefore 0 equals y. And in the third one, I have negative 2 plus 4 equals y, or 2 equals y, and therefore that's my corresponding value. Now if I did the next one, I could see by the pattern here, it has to be 4. So I can just put that in because I know it's going up by 2 each time. Okay? Then what I want to do is graph it. Now because this pair here has y of negative 2, which is down here somewhere, I'm going to ignore that pair. I shouldn't have graphed that one because it's not going to. So I'm just going to graph these 3 points right here. So when x is 1, y is 0. That is x, y. So x is 1 and y is 0. That's the first point. When x is 2 and y is 2, that's that point there. And when x is 3 and y is 4, it's that point right there. So it's 3 on the x and 4 on the y. And there's my line, and that's my graph. That's what my graph should look like. And actually, if I extended this down, I would see when x is 0, oh, sorry, it should be there. Y is negative 2, something like that. Ignore that last part. Question 3, all you're given is a context. And this point it says a cheese pizza costs $14.50 plus $1.50 per topping. So the first thing you want to do when you're given a context is see if you can define what things you know. So for this one, you know the number of toppings and you know the general cost. So I'm going to let small t represent the number of toppings. And I'm going to represent C with the cost in dollars. Okay? And then I'm going to fill in the values according to the context. So when there is 0 toppings, I would be buying a cheese pizza, and therefore it would cost me $14.50. If I bought 1 topping, it would be $14.50 plus $1.50, which would be $16. If I bought 2 toppings, it would be $17.50. And if I bought 3 toppings, it would be $19. Okay? So all I did was I just made up examples of how many toppings I bought. I just chose it like I would in a random equation, 0, 1, 2, 3. And now I have a table of values. Now my next part is to take that table of values and determine the equation that matches T and C. So just like I did with X and Y, I'm going to write down the relationship between toppings and cost. And I'm going to search for my coefficient. Now my coefficient is the difference in Y. In this case, it's not really Y, it's cost, which is 1.50. Divided by the difference in x, or in this case t, which is 1. So 1.50 divided by 1 is simply 1.50. So that is my coefficient, and that makes sense because $1.50 multiplied by the number of toppings you buy would be the cost for your toppings, because if you bought 2, it would be $1.50 times 2, which is $3 for your toppings, and so on and so forth. Now, even though I know what my constant is going to be, I'm actually going to substitute. So I'm going to take the first value here. T is 0, so I'm going to substitute 0 for my T and $14.50 for my C. $1.50 times 0 toppings is 0. I'm going to check to see if they're equal. 0 does not equal $14.50, so I require a constant of $14.50, which means the equation that represents the relationship between toppings and cost is 1.50 multiplied by the number of toppings plus a constant of 14.50, and that represents your cheese pizza, right? And that will always equal the cost of everything. So if I asked you what would a pizza cost with 10 toppings, you could simply take your equation, substitute your 10 toppings for T, and simplify it to find your cost. In this case, it would be $15 for your toppings, plus $14 for your and 50 cents for your cheese pizza. So the total cost would be $19.50. So when when the toppings equals 10, did I do something wrong? Oh, yes, $29.50, sorry. Your total cost for the pizza would be $29.50. That's just an example. That's not part of the question, but that's just an example to show you how we could use the equation to solve missing values. And your last question, you're given a table of values for x and y, no context. You don't know what x represents. You don't know what y represents. There could be a relationship. There could be like a pizza question that it would work for, but in this case, we don't know. We just have an equation. So you're to provide a graph for it and an equation. So we're going to look for the equation first. The difference here is 4 each time, and the difference here is 1 each time. So the difference in y divided by the difference in x will be the coefficient, which is 4. So in the relationship between x and y, 4 is your coefficient. Take your first ordered pair, or any one you want, substitute the value of x in that equation, and substitute the corresponding y value. See if they're equal. They're not. It requires a constant of +2 to maintain equality between the two sides. And therefore, the equation that represents this table of values is 4x plus 2 equals y. Okay, so 4x plus 2 equals y is your equation. I now want to graph it. So my x-axis, I'm actually going to shrink it down. So I'm going to put that little thing there, and I'm going to put 5, 6, 7. So what I've really done there is I've omitted x1, x2, x3, and x4, and I've just shrunk that line down to where it starts at 5, 6, 7. You don't have to, and in fact, if you didn't do it, you could just go 1, 2, 3, 4, 5, 6, 7. That's fine too. So we have 1, 2, 3, 4, 5, 6, 7. And then we have up here, we're going to shrink this line down for sure, because I'm going to go up by 4s, and I don't want to go 4, 8, 12, 16, 20. I want to omit those ones. So I'm going to shrink all those ones down. This little thing means you shrink it down. My first number is going to be 22, and then 20, so 6, then 30, then 34, because it's going up by 4s each time. And then I'm simply going to plot those points. 522 would be right here, 626 would be right here, and 730 would be right here. And there's my line that shows the relationship. Now the additional part here is, given this equation right here, when y is 82, what's the corresponding x value? So when you're given this type of question, all you have to do is substitute the variable that you know to determine the one you don't know. So in this case, I don't know my x, it's empty. So I'm going to leave it as x, but my y value is 82. Now all I have is a two-step algebraic equation. Subtract 2 from both sides to start isolating for x to determine its value. Divide both sides by 4, and x will equal 20. Okay, so I used algebra to solve the missing value of x. And in your second example, I know the x this time, but I don't know the y. So in this equation, I still keep my original equation that matches it, but this time I'm going to substitute the x value for 120 to determine the y. In this case, when x is 120, I'd simplify this to be 480, and 480 plus 2 is 482, and therefore my corresponding y value would be 482.